Hello students, welcome back. So in this session, I'm going to be talking about matrix addition, subtraction, and multiplication. This is in context, this is related to linear algebra. So I'm assuming that you know at least basics of your high school matrix multiplication, addition, and subtraction. So let's say you want to do, let's start with addition, okay? Let's say you want to do some addition of your matrices. So if you remember from your high school, your matrix, they should have the same shape, okay? That's the number one thing. And when you do your addition or subtraction, it's going to be doing element wise. So what do I mean by element wise? So let's say I have these two matrix, matrix A and matrix B, and both of the matrix have exactly same shape. 2 by 3, 2 by 3. That means you can do matrix addition. So you do element wise addition. So in this case, you take 1 and you add to the 5. Okay, 1 plus 5, and the answer is 6. You take 2, add with 7, 2 plus 7, and the answer is 9. And same thing with 3, add with 9, and 3 plus 9, 12. And likewise, you can perform the matrix addition for every single element like this. This is what you mean when I say matrix element wise matrix addition or subtraction. Okay, so let's say I have this matrix A and B. I want to add them. Okay, so I create a matrix A. This is my matrix A. This is my matrix B. And the shape of A is 2 by 3, and the shape of B is also 2 by 3. And you perform matrix additions. All you have to do is just A plus B. That's all you have to do. Just A plus B, and that's going to add this matrix with this matrix right here. So I'm using NumPy array to simulate matrices. Now, what about matrix subtraction? Exactly same logic. The only difference is instead of using plus, you're using minus. So it's going to do element-wise subtraction, and you want to make sure that both the matrix have exactly same shape. In this case, both of them do have same shape. So let's look at one element. Let's look at this one right there, 2. How did you come across this? How did you came with this element or this number? You say 6 minus 8. 6 minus 8, and the answer is minus 2. This is how this number minus 2 came about. Okay, so let's look at how we do matrix subtraction. Fairly easy, by the way. So subtraction, your A basically make sure it's a same shape as your B. So this is 2 by 3 matrix, and B is also 2 by 3 matrix. So you can perform subtraction, and I'm doing A minus B, and that gives me my result right here. Okay, so this is my A minus B right here. All right, now let's talk about matrix multiplication. So matrix multiplication, it requires that the number of columns in the first matrix, okay, it must match number of rows in the second matrix. That's the very important part. So anytime when you do your matrix multiplication, if you remember from your high school, this is the rule that was followed. So for example, if your A, okay, this A right here, okay, let me just open up my marker. All right, if let's say your A, okay, is m by n, sorry, n by m. Okay, your A is n by m, and your B, okay, your B is m by p, m by p matrix. So you want to make sure that this number and this number should be same. As long as these two numbers are same, you can perform matrix multiplication. Okay, then it's fine. Now your final output, the shape of this is going to be n by p. So this is going to be shape of your matrix. So let's look at an example right here. In this example, my A is 2 by 3, right? This is my A, 2 by 3. And look at my B. What is the shape of my B? It's 3 by 2. It's 3 by 2. In this case, this 3 is exactly same as this 3. As long as they are same, that means you can perform matrix multiplication. And your final matrix, okay, the shape of your final matrix is going to be this 2, okay, let me remove this 2 by this 2 by this 2, 2 by 2. All right, okay. Now let's look at another example just to have a little bit better understanding. In case if this did not help you, let's start with another example. Let's say I have matrix right here, 3 by 2. This is my A, 3 by 2, and my B is 2 by 3. You see, this 2 is same as this 2. That means you can perform matrix multiplication. And when you do it, your answer, your resultant matrix, the dimension of that or the shape of that would be 3 by 3. 3 by 3. That would be your shape of your matrix. And one final example, this one right here. So in this case, I have a matrix. Okay, this is my matrix A, and this is my matrix B. So my matrix A is 3 by 2. Okay, matrix B is 2 by 5. So when I multiply them, okay, it's going to give me a matrix. And the size of this matrix, the shape of this matrix is going to be, by the way, this 2 is same as this 2. It's going to be 3 by, okay, this 3 is right here, by 5, which is this 5 right here. All right, 3 by 5. Okay, so this is how you can determine the shape of your final matrix. And I'm assuming that you know how to do your matrix multiplication. So in NumPy, when you do matrix multiplication, this is the notation they use. This is one of the notation, by the way, they use. There is another ways to multiply matrix. So I'm assuming that you know how to do this calculation right here. So this is from your high school math. Well, in NumPy, it's very simple. All you do is you define your matrix like this. Okay, so let me just copy, paste it over here. All right, so this is my A, this is my B matrix. So there are three ways to perform matrix multiplication in NumPy. This is the first way. You can say A at the rate B. All right, A at the rate B, and that's going to give you your answer right there, 2 by 2. Okay, or you can also do like this. You can say result equal to np dot matmult. Okay, so this is a short, this is a inbuilt method, but basically it's a short for matrix multiplication. And you supply your A, you supply your B, and it's going to multiply these two matrices together. As you can see, answer came out to be same. Or you can also do this way. You can actually use the dot. There's an inbuilt method called dot. Although I would not recommend using this anytime when you're doing matrix multiplication. Generally, I prefer matmult over there. But I've seen people do this way too. So this will also give you the same result. So in this case, you have matrix multiplication. You're saying np dot a comma b. Okay, now let's look at another example. So in this case, my matrix A is a 3 by 2 matrix, and matrix B is 2 by 3. Okay, so your 2 is same as this 2. Great, you can do matrix multiplication. And your final matrix, okay, the final product would be 3 by 3. Okay, the product is going to be 3 by 3 matrix. All right, so when you run this, and there you go. So you can again do it three different ways. You can do this way, or you can do this way, or you can do this way. All three of them will give you exactly same answer. Okay, now let's do one last example. Matrix multiplication. In this case, my A is 3 by 2 and my B is 2 by 5. So your 2 is same as this 2. Alright, so that means you can perform matrix multiplication. And your final product is going to be 3 by 5. So your product is going to be 3 by 5 matrix. So if you multiply this thing, if you multiply these matrices, you can see your answer is 3 rows and 5 columns. So 3 by 5. And you can do either one of them. All three methods, they produce the same result. I would actually, generally I don't use this method. I prefer this one or even this one. This is good too. Okay, dot product now. So dot product, we use the dot product function for three different things. Number one, to compute inner product of two vectors. So if you remember from your high school math, sometimes you had to do inner product of two vectors. So you can use dot product, or you can multiply a vector by a matrix. Okay, you can also use dot product to multiply a vector by a matrix, or you can also use to multiply two matrices. So you have these three different ways you can do. You can actually to compute inner product of two vectors, and you can multiply a vector by a matrix, and you can also multiply two matrices. So how do we do that? Let's try to perform a dot product between two vectors. So we have two vectors. Okay, these are the two vectors. and we want to calculate your dot product. This is actually similar to the ones that we study in our school. So let's say my vector v is this and vector w is this. And all you have to do is just type np dot v comma w, or you can say v dot w, okay? V dot and w over there. So that's going to do v dot product of v and w. So this is same as v dot w. Okay, this is exactly same as this. My v, this vector, is this one right here. Okay, and my w is this one. All right. All right. And when I run this, they both produce the same answer. So I can I can do this way, or I can do this way. They both will give you the same answer. All right, now let's talk about dot product between matrix and a vector. You can also do dot product between matrix and a vector. Now, this is important that the order matters. So if you want to do matrix A dot product with X, okay, so if A is m by n matrix and X is n as a shape is n, then your np dot A X like this, okay, this dot product will actually have a shape like that, m. That will be shape. All right, so this is my matrix A. Okay, this is my matrix X, and I'm doing dot product of A dot X. So basically, this is what I'm doing. I'm saying A dot X. Okay, this is what I'm doing, A dot X. So this function, this is what it does, and my result is right here. Okay, gentlemen, thank you.